Hi, everyone, again. So I've personally, and I've been to many conferences where fake news has been talked a bit to death over the last few years, from ACRL to ALA to other conferences. So going into this symposium, I asked myself, what hasn't been said yet about fake news? And I know we've all as librarians talked about information literacy, we've talked about the problem of fake news. But the thing that I did not see brought up very much in librarian context was the topic of these automatic detection apps, trying to use computational methods to predict fake news and sort of stop it in its tracks. I had recommended apps to people in information literacy classes that I taught and in conferences from lists that I'd found on the internet of different apps. I'd tried them out. I had no idea how they actually worked. So, like a good researcher, I decided to create some research questions going into this talk, and I will preface my presentation by saying I am not going to demonstrate all of these different tools and apps out there. When I say apps, I'm talking about mostly browser extensions. It seems to be where the technology is going right now, things that you can overlay in your Firefox or Chrome browser so that when you're browsing social media, when you're browsing Google results, little flags will show up on articles that are tagged as fake. So I'm not going to go into every single specific example out there. I will discuss a few that lead to my overall points about how this works. So my main research questions were, how do automatic fake news detection apps work? And do the apps currently available publicly work well enough to combat fake news in a meaningful way? So to give some context to this first, there's basically three methods that can be used to detect fake news. There's fact-checking by experts who are human. There's crowdsourced flagging or annotation of content. And then there's computational prediction, which is another fancy way of saying automatic detection of fake news without human intervention. The first two methods come more from a journalism standpoint perspective. The last one comes more from engineering. The advances we're seeing are really in computer science and engineering there. So I'm going to break each one of those down a little bit over the next few slides. And I know there are some of you in the audience who probably understand how this works a lot better than I do even, but I wanted to give as quick of an overview of this topic as I could so we can get our heads wrapped around it a little more. So fact-checking by human experts, this is probably the detection method that most of us, especially librarians, are the most familiar and comfortable with. We're constantly sending people to Snopes, PolitiFact, FactCheck.org. There's a number of these out there, and they're very accurate, they're trustworthy when you know the right ones to look at. They rely on journalistic expertise, critical thinking. There's a lot of groups that are doing this out there. There are even networks of journalists who are trying to make fact-checking and sharing of fact-checking more efficient. So groups like First Draft, which is sort of an international network of journalists, created a platform called Crosscheck, where essentially they can sort of crowdsource their fact-checking. So one fact-checker would post it, and then the whole network of journalists who are part of that social network will see it. There was an app called This Is Fake a couple years ago. Had anybody heard of that or used This Is Fake? It was created by Slate, and it was basically run by Slate's fact checkers. So it didn't really do anything automatic. Slate's fact checkers would put fact-checked articles into their database. The app would flag them when they came across them in social media. And it's now defunct. It's not available on the Chrome extension store anymore, probably because it was too time-intensive to maintain. And that brings us to the negative aspect of human fact-checking, which is that it's very time and labor-intensive. It's not very scalable. It's hard for experts to keep up with the huge amount of false information and misinformation that's being produced. And it's also very difficult to catch fake stories before they go viral. The last talk we had a great definition of viral, and if it equals a certain amount of shares, before Snopes or PolitiFact are going to check that statement, it usually has to reach a certain level of popularity or at least be out there for them to find before they're going to bother putting the time in to do it. So it's sort of like at that point, is it too late? Right? If we wait until something goes viral to fact check it, is it already too late? The other downside to this is that any of these tools or websites, the consumer needs to know about them. in order for them to be helpful. And we see that with our students and the public that we're working with in fact checking, right? So if they don't know that Snopes exists, or they don't know to go to factcheck.org, how are they going to fact check their sources? So I came across a really interesting statistic, 10 to 20 hours. This is the amount of time between when a piece of information, a misinformation, first gets shared on social media, and when a piece of contradictory information debunking that fake news story gets shared. So I have kind of an open question for you all. Do you feel like that's a short time or a long time? Too long. Anybody feel like it's pretty quick? My initial reaction was 10 hours, that doesn't seem too bad if we're talking about humans, but if you're talking about internet hours, and how many millions of times these things can perpetuate, and I hope to later show you a graph showing how quickly these things can perpetuate. It could be forever. And so this is where other methods might be more helpful. All right, so crowdsourced flagging or annotation, this is still relying on mostly humans, but it's opening it up to the general public. So when you flag something as false news on Facebook, that would be crowdsourced annotation or flagging as a means of fake news detection. It's much faster and more scalable. It can be more easily converted into apps a little bit. Some platforms out there that do this are Fiskit and Hypothesis. These are websites that you join them and they allow you to kind of group edit something or put flags and put links citing the credible material into stuff live on the web that anybody in those networks can see. And it's actually very accurate. There was a scientific study that I came across that showed that when they looked at crowdsourced flags of fake news articles, those people were able to predict with a very high degree of accuracy the articles that actually were fake or not, and they cross-checked it against real fact checkers. So it actually is a pretty accurate way to do it. But there are still drawbacks that are similar to relying on expert fact checking, and that includes people who do this are usually not paid. There's usually voluntary participation. You got to recruit people to do this, and there could be some labor issues involved in that. And you can also, this can be misused by malicious accounts, bots, trolls, etc. So it's very easy for some troll to make an account on a fact-checking website and flag a bunch of things, and then it's throwing off their research, basically. And so that brings me to the third, computational prediction, automatic detection. The pros of this are that it's very fast. You can scale it up to the size of entire social networks or search results, search engines. You can much more easily adapt these kinds of things into apps and browser extensions. On the downside, the math is actually very complicated. The programming is actually very complicated, much more so than it might seem to an outsider. And it still relies on data sets that have been hand-coded by human experts in order to train and test these kinds of apps for the most part. And I also discovered in my research that there are actually very few completely automated tools currently on the market. Some examples in the corner include Factmata, Project Fib, BX Detector, HoaxE, Check This, Fake News Detector. Do these ring a bell? Has anybody used these or heard of these before? Can you raise your hands if you've heard of any of them? Okay, so a few. I think this is still, pretty cutting edge stuff. These have a range of degrees of automation, which I'll talk about a little bit later in my talk. All right, so we can kind of start to answer my first research question. How do automatic fake news detection apps work? And the answer is, it's the algorithms. Right, now there are people here who probably understand what an algorithm is and does. I use this word a lot, maybe without fully understanding it. So a quick, very bare bones definition in plain English is that algorithms are basically just a mathematical formula or code that use past events to predict future ones. And so when we hear the terms learning machine or machine learning, learning algorithms or AI, it's really referring to algorithms that work by the more items that are accumulated in their data set, the more accurate their predictions become over time. So they have the ability to grow and kind of learn from past data sets. So there's basically three major types of fake news detection algorithms that are being used: content analysis, user behavior analysis, and diffusion analysis, which tracks the social network spread of fake news. Most of the more cutting edge approaches are using some combination of two or more of these. So content or textual analysis is where matrix algebra and computer programming meet linguistics and media studies, and it makes my English major brain really happy to think about this, because basically what it's doing is using linguistic properties of the text of fake news articles themselves to try to determine whether it's fake news or not. Less sophisticated content analysis algorithms, like the one used by Project Fib, basically do keyword matching. They're looking for trigger words in fake news articles, and then they try to match these trigger words against their pre-existing data set. More sophisticated algorithms use natural language processing, which is sort of the technology behind something like IBM's Watson or Alexa or Siri. And those are looking at the larger context of a fake news story. So they're looking at perhaps the author, perhaps when it was shared, and perhaps images, although really image analysis is lagging much more behind text analysis. What all these algorithms are trying to do is gauge the probability that a story is either real or fake, and they often give them a probability score of some sort. One of the more interesting areas to me is algorithms that are using psycholinguistics. So they're looking for language in an article that is sensationalized or emotionally triggering, because we know that emotionally charged language in memes get them shared more, and that people who create these, I said memes, but memes and fake news, people who create this type of content are trying to get us to share it by playing on our emotions. So that seems like a really promising area. There's a whole other type of algorithm for fake news detection that looks at user behavior and user engagement, and it doesn't look at the text at all. It does not care what is in that fake news article. Instead, it's basically looking at who shares it. And research is showing that who shares fake news can very accurately predict who shares the news can predict whether it's fake or not. And so these algorithms are essentially tracking users' shares and likes, and they get kind of user profiles or user reputation scores. So they're looking for who are the good actors and who are the bad actors. And they can also vet out what's a bot, what's a troll, cyborg, et cetera, using that method. So this usually is applied with another type of algorithm or fake news detection approach, but there seems to be a lot of promising research in this area, and HoaxE is one tool that uses this a little bit. We suspect that Facebook's fake news efforts are using user behavior analysis as well. And then there's one last type of algorithm that's being used for fake news detection, and that is diffusion analysis algorithms. These are tracking how posts go viral, and research has shown that fake news stories spread differently than real ones. They have different kind of nodes of origin points, and they get shared differently in a less organic way. And so there's research being done to try to figure out how to harness that and track these things across social media. The goal with this, I think, is really key, and it's to stop the spread of fake news before it goes viral. And so that's why diffusion analysis is really interesting, but often this is used in combination with one of the other two methods. All right, so for all the nerds out there, here's some different algorithms that researchers are using in my lit review that I did for this. I'm not going to be able to explain all of them, but I will say that natural language processing is very important in text analysis. Boolean label crowdsourcing is important in user behavior analysis. And neural networks, the one listed on the bottom, is very important to diffusion analysis. There's a lot more of these things that go into it as well. So for people who are more visually inclined, this is what an algorithm might look like. This example was from an article by Figuera and Oliveira. I really recommend that article for someone wanting an overview on the topic of automatic fake news detection. This was an example they used. This algorithm is supposed to use content analysis to determine if an article is fake or not, and then cross-check it against a data set. And so in the article, they go line by line and say which pieces of this are very doable with current technology that we have now, and which pieces are really complicated or still need to be researched more. All right, so that kind of answers the how they work very broadly. The next question that I had is, are there publicly available apps on the market right now that work well enough to combat fake news in a meaningful way? And I really wish that I had a great list for you all of the ones that are scientifically tested and that work really well and the ones that are not, but I do not. There's just not enough in the scientific literature on this right now to tell. And that's partly because truly automated fake news detection hasn't been achieved yet. The apps that are out there, things like BS Detector, Check This, Fake News Detector, have not really been evaluated from a research or scientific perspective. And the scientists are creating their own, the engineers creating their own algorithms and their own pieces of this puzzle are not quite at the point where they're making them into apps that they're putting on the market yet. So we have kind of a little bit of a gap there. All right, so here are some concrete examples of different fake news automation apps that are out there. And I put them on a scale of not automated to fully automated. So on the not automated side, obviously things like expert fact-checking sites, crowd flagging tools, those are not automated. Then you have BS Detector. Who has heard of BS Detector? Yeah, so that one's been around for a couple years now, and it basically is a browser extension that will flag things in your social media feed. I've used it. It seems to work pretty well. However, I learned through this process of research that it's not really fully automated very much at all. So essentially what it's doing is it's looking at articles, looking for the links in those articles, and then comparing them against a hand-coded blacklist of suspicious websites from open sources, which people have been adding to. But that means humans are involved in continually updating this list so that the BS Detector app can pull from it. So it's not really guessing if something's fake or not based on its content or user behavior or anything like that. On the other side, the fully automated side, you have FactMata, which seems to be, it's been a little bit discussed in the literature. It seems like it's pretty cutting edge. It was a startup. It started from researchers, I believe, in the University of London. It's backed by Google's Digital News Initiative. And it uses a combination of first text analysis and then user engagement analysis. But it's not a free product. It's not really downloadable for you and me. And they've been marketing themselves to advertisers, publishers, journalists, and what they call on their website large-scale online communities, which I think is their code for asking, please Facebook and Twitter and Google, please buy our startup. We want to work for you now. So I think that's kind of what's going on with them. They had sort of a nice glossy website explaining their product, but it was hard to really see evaluations of it. In the middle, there are all a range of tools. I'm not going to go over each one. The slides will be shared. But essentially, the other tools use some combination of automatic detection and human intervention or human fact-checking. So I wanted to just highlight two of them that are hybrid methods. One is HoaxE. HoaxE is from the University of Indiana, and it basically works by sending web crawlers to identify fake stories and then auto-link to stories that debunk them. And this is kind of a light content analysis because they are just looking at keywords. They're not really using learning algorithms in that point. And it does rely on expert fact-checking websites. I think they mentioned Snopes and factcheck.org. They have a whole database of these things. So somebody still has to fact-check the information first before HoaxE can determine if it's fake. The cool part about HoaxE is that it monitors the spread of fake news using social media APIs, and that's the diffusion analysis part. And all of the data that it gathers gets stored in a database and displayed in a really cool visual dashboard. And so that's very useful for future researchers. I was hoping to show this to you if we have time. Let me see if I can get out to the web. So here's HoaxE. Does anybody have a favorite fake news example to show? I could even just do, let's do the one about like Sarah Sanders and Roseanne. Let's see if that works. I'm never sure with HoaxE how specific you have to be when you're searching for fake news. And it works, it's pretty well embedded with Twitter. It seems with a lot of these products, they either work best with Facebook or with Twitter. They're not necessarily universal. HoaxE's being kind of slow. All right, so this is what one of their diffusion analysis graphs looks like. And so you can kind of see over time. They also, you can do it as sort of a straight timeline as well. That's what's on this side. You can see that things dramatically pop up, and you can see different nodes of sort of the people who are perpetuating these things the most. So Politicus USA is one of the centers here. And you can also search for real news on this as well. So HoaxE seems like a pretty cool tool, although it's not really an app right now at this stage. Let me go back into my... Oh, I went back to the beginning. Sorry, folks. I didn't expect it to do that. Anybody know how I go to the skip to another slide? I just got to scroll on through. All right. Presenter mode. The perils of presenter mode. Okay. Almost there. So I wanted to get to Facebook in my, there we go. Okay. So the other hybrid method is Facebook. And the caveat here is we don't really know what Facebook is doing to combat fake news. And after our keynote speech at noon today, I'm feeling much more scared about Facebook's ability to be on top of this. However, they have shared a little bit of information bit by bit. Some background here, immediately after the 2016 election, Facebook basically said this problem is too big and we shouldn't be the arbiters of truth. And then people gave them a lot of flack for it, and so they've rolled out different methods and tried different fake news methods, and they use a hybrid method. So users can flag content as false news on Facebook. That's crowdsourcing. And then it uses algorithms to determine which of those posts are likely to be fake. And that would be the automatic detection part. And based on their algorithms ranking that fake news, the content is reviewed by human moderators. It's either Facebook or a third party. I was reading different accounts about that, but that involves expert fact checking. So they're kind of doing all three options. And then they're taking additional steps to try to make sure that the news doesn't spread as much. At first, they were putting banners over posts that were fake that would say this might be unreliable or this might be false news. And then what they discovered were that those banners actually increased clicks on those posts. So users were intrigued and then clicked on it. So they stopped doing that, but now what they're doing is making the posts smaller, so the links will appear smaller in your newsfeed and be less attractive. They're also experimenting with putting debunking stories or other related stories next to it in the feed. And they're just removing stuff as well. They've like cracked down a little bit more on false accounts and things like that. So overall, there are some gaps in the scientific literature. I touched on this briefly earlier, but basically you've got the engineers over here looking at algorithms, researching things, and they're not quite at the point where they're able to turn that into apps yet. And then on the other side, you've got for-profit companies like FactMata or Check This by Metacert, which is a cybersecurity company, who are not very forthcoming about how their apps work. And there's also not really evaluation of other products that are out there that might work okay. There's a lot of financial incentives behind some of this as well. And Facebook has filed numerous patents for fake news detection in the last year or so as well. But I would say the largest gap in the literature that I came across was an almost complete lack of discussion of the free speech implications of using some kind of bot to automatically detect and possibly suppress content. One article talked about this, and that was the Figuera and Olivier article. And I pulled out this quote because I think it kind of sums up the concern. A judgment on the value of information should not be performed exclusively by machines. In case they are given total control to decide which information is displayed, freedom of speech must be protected at all cost. So Facebook themselves seems to have ascribed to this, especially at the beginning in some ways. They said, we don't want to be the arbiters of truth. And yet, things like this are continuing to happen. So this was just yesterday morning. My friend Max, who is a professor at Earlham, posted this on the left here. In a move both laudable and creepy, Facebook identified a source of fake news yesterday and has completely removed all record of it. On the one hand, excellent. That's what should happen. On the other, informing people who'd shared it would have been similarly useful because now there's just a gaping hole where conversation about the piece used to be. And then he references our friend Alyssa, who had reported the post. So it brings up some really good points. I really like Max's phrase, laudable and creepy. I think that kind of sums up where Facebook is right now. The post in question, I responded and I asked if Max could tell me what the content was, and Alyssa had actually taken a screenshot, so she shared the one on the right, and it was a post from a fake Sarah Huckabee Sanders account talking about her supporting a character from The Handmaid's Tale in reference to the White House Correspondents' Dinner. And I think Facebook was more gung-ho in deleting that because it was a fake account. And they've been cracking down on fake accounts rather than necessarily the content of the post. I think that might be what's going on here. But it just brings up some interesting kind of contradictions about Facebook's approach. So to sum up, we are getting closer to fully automated computational detection of fake news. We're not quite there yet. And the main benefit of doing this is that it can scale up to the level of entire social networks, and it can help stop fake news from spreading virally. That said, journalists and fact checkers are not out of a job. Fact checking is still very important because a lot of these algorithms to be trained need hand-coded data sets where someone who's an expert says this is fake, this is not. And librarians are not out of a job either because media literacy, information literacy are still very important for users to recognize fake news and flag it and stop sharing it, and also use all of these apps and tools that are out there.
We've got 2 minutes left till break, so I'll take one question. I already see a hand up.
Hey, thanks so much. Well, you briefly talked about the potential ethical problems in terms of suppression of free speech, especially if a lot of these algorithms are being developed in a black box and we don't know how content's being suppressed or not. Did you find anything in your research about the potential privacy implications of obviously profiling users to figure out which users are fake or not, and also potentially giving I don't remember the phrase, whatever the score, that seems really creepy to me. So I just wonder if anyone's talking about potential privacy implications.
My understanding of where the sort of academic research is in this field is that when they talk about user reputation and scores and user analysis, they're really looking at aggregated data. So it's not necessarily tied to your name and your address and stuff. Given what we've learned about Cambridge Analytica and their ability to connect these things pretty easily to voter rolls, maybe it's not as private as we think. But in terms of the scientific research that's coming out of universities and other big tech kind of startups, we don't know so much about the private sector, but the public sector has been very careful about identifying those kind of things. And it's really looking at huge scales. So it's less concerned with, are you a bad sharer, than is this type of user who shares in this type of way more likely to be a bot? But you're right, there definitely could be privacy.